So if I describe the beef cattle industry, there are really a couple of kinds of breeders. One is a commercial breeder that typically has crossbred cattle. They're the ones that are producing the calves that will end up becoming beef. And then there's seed stock producers. Seed stock producers are sort of higher up the pyramid, so they produce the genetics that are sold or provided to the commercial cow-calf producers that ultimately become the beef on the table. And so at Freeman we have both. We have a crossbred commercial herd and we have Santa Gertrudis, which is our seed stock herd. Here at Texas State we've just started a program with Santa Gertrudis and the Santa Gertrudis Breeders Association. We are working with Santa Gertrudis breeders to collect DNA samples from their animals and then following those animals throughout the production life cycle or throughout their lifetime to measure economically important traits such as birth weight, weaning weight, yearling weight, milking ability, carcass quality, and the amount of fat, because we want an efficient animal. We want one that can achieve the proper finish weight at a reasonable time period and do so with as little feed as possible to reduce the cost. And so some of the genetic improvement research we're doing are looking specifically at those traits. For instance, feed efficiency. If we can find an animal that can add weight on, say, 20% less food, then that's an economic benefit to the cattle breeder, but it's also a benefit for the environment, because if it's eating less food, it's producing less greenhouse gases, and so that's just a win-win situation. Santa Gertrudis cattle, with their attributes, they are able to be more efficient. The breed was developed by the King Ranch in Kingsville, Texas. They were looking for a breed of cattle that would excel in the South Texas environment, much like the environment we have here in San Marcos. They were able to develop a strain of cattle that had very high quality beef, that were very good mothers, that were very adaptable to sort of the hot, humid climate of South Texas. We think of this as sort of an integrated approach, and so the cattle herd is part of that, but so is the soil and crops research that's going on at Texas State. It's all a big ecosystem. Cattle are part of that, and we're trying to produce cattle in a sustainable way that help improve the environment rather than be a detriment.
Freeman Center is 3,500 acres, and our primary use is teaching and research activities, and we do outreach activities for the community also. We're in Fernando pasture underneath what we nicknamed the Granddaddy Oak. 2016 was when we started doing some restorative agriculture out here, trying to remove some of the woody vegetation and restore the oak savanna. Starting 2020, 2021 was when we started getting more of a research idea behind it. Regenerative agriculture is the holistic approach of improving and enhancing the ecosystem and primarily looking at improving the soil. Regenerative agriculture is tied into flash flooding and water support through the fact that we are making the land be able to retain water at a higher level, and it will also allow us to slow down those flash floods by having the proper vegetation out here to slow the flow. We're going in and removing all the woody vegetation in naturally open spaces. We have some target herbicide treatments afterwards, and now with humus soil and biochar being introduced, we will be working to apply those different soil modifications to improve the soil quality in the different spaces. Fire is very useful as a land management tool because it allows us to get away from using any herbicides and to not have to burn as much diesel and stuff in the mechanical clearing. We will be able to go in and put a fire break around an area that we're trying to restore and then do a controlled burn in that area, and it is going to remove the woody vegetation. And most of the species around here have actually evolved in a way that they live in a fire culture and they will come back stronger than what they were when we started. When fires are properly controlled, we can keep them to the space we need. So our goal with prescribed burning is to get to the point where the 1,000 acres that we're trying to restore to the oak savanna that it was, that we can go in and do a fire every 3 to 5 years, depending on what Mother Nature is giving us for growth and that type of stuff. And we're gonna use smart systems like vents, hopefully, or a virtual fence system where we can control the cattle in a small area. And we will have to work on partnerships with other people in the area to have the manpower to be able to safely perform those burns. We're hoping sometime here in the next 5 years.
My lab is centered around ruminant nutrition. We aim to enhance the sustainability of beef cattle production. So we have a herd of ruminantly cannulated steers here at the Freeman Center, and we feed them novel feed additives. We assess different feeding strategies and basically assess sustainability. So our cannulated herd of cattle have basically a hole or a portal in part of their stomach that's called the rumen, and that's where all the fermentation and the magic happens. This is why cattle and other ruminants can turn grass into beef and milk. So we use these special surgically implanted animals to give us really in-depth data as to what's going on in their digestive system. In beef cattle production, especially cattle that are grazing like they do at Freeman Center, a lot of different times of the year, forage quality gets low. Maybe there's a drought, maybe there's a rough winter, and so it's very common for beef producers to provide protein to those animals so they can better use the forage or the grass. And so what we're interested in is novel proteins and other feed additives that help the animals utilize the grass better, but also these proteins need to be sustainable. Our lab was the first to conduct research on black soldier fly larvae for beef cattle. This is a novel insect protein. The thought is that it could replace some of the conventional proteins that are very expensive for beef producers, associated with a lot of water or land input, or again, maybe deforestation. Our lab assesses all kinds of different feed additives. New research that we're conducting involves feeding biochar to cattle. This is a pretty novel line of research because biochar has always been utilized as maybe a fertilizer and just spread on the land. Our thought is, can we feed biochar to cattle? It basically passes through the animal and then is deposited on the land with their manure. What we need to make sure is that the biochar doesn't negatively affect the animal. We want the animal to still be able to eat the grass, that they're grazing, be able to digest it, and not have any negative health outcomes. We're trying to determine how much can we and should we feed to cattle without negatively affecting them.
My work at Freeman Center involves developing Bobcat Farm and managing its operations, as well as conducting research there. Freeman Center is a valuable resource because it is a place where we conduct a number of classroom laboratories, including for crop science and soil science. Bobcat Farm is an 1.5-acre fruit and vegetable farm that is what you'd say regenerative, meaning that we are working on building the soil and the functioning of the ecosystem so that that soil holds more water, and we're growing crops in a way that lead to improved crop health and plant vigor that translate to more nutrient-dense food. Ultimately, my research is focused on water through the role that soil plays in the water cycle. When the soil is degraded, when it rains, the water isn't absorbed, it runs off. And then from there, you don't have the water being held in the soil to be available to the plants, and the plants that are eaten by animals, et cetera, et cetera. How I employ humus soil and biochar is through my research and then also teaching. So we have been producing biochar here at Freeman Ranch using the slash wood from Freeman Ranch. We're pyrolyzing it, we're burning it, we're making biochar from it. We are then blending it with our humus soil. Humus soil is, technically it's a compost, but we distinguish it from compost because it's so different. It has many different attributes than our traditional composting method. Ideally, we'd like to look at the biochar and the humus soil that we're making here at Freeman to be able to put out onto more acreage at Freeman to restore the rangeland area as well. The animals could help spread that biochar kind of the way that birds spread seed. We're looking at this in a myriad of different ways to help heal the ecosystem.